Hello. The hydrology video tutorial is divided into 4 parts, 1 theoretical section and 3 practical exercises. Regarding the theoretical part, to develop hydrological models in WEAP, it is essential to clarify what a catchment is in WEAP and the hydrological methods available in WEAP. Because the rainfall runoff soil moisture method is more robust and widely used, it is addressed in more detail. In respect of practical exercises, in the first exercise, we will develop a hydrological model in WEAP using the soil moisture method. In the second one, we will calibrate that hydrological model with the Model Inspector tool, which has embedded macros for exchanging information with WEAP. This tool must be modified to work with a specific model. You will not be able to use it in any model unless you modify the macros and formulas within the file first. Finally, in the third practical exercise, we will use the catchment delineation mode in WEAP. In the first theoretical session, we will address the catchment concept. To develop a hydrological model in WEAP, it is necessary to divide the basin to be modeled into adjacent catchments. A catchment is a user-defined area within the schematic. You can specify processes such as precipitation, evapotranspiration, snow and ice accumulation and melt, runoff, irrigation, and yields on agricultural and non-agricultural land. When you create a catchment in the schematic, a window pops up to select the option that will apply for this catchment, including whether irrigation will occur in the catchment. If irrigation is selected for a catchment, you will be required to create transmission links from a supply to the catchment for the irrigation water and additional input variables. You can check the tutorial and the help of WEAP for further information about how to add irrigation to the catchment. 7 steps are suggested to divide the basin into catchments when developing a hydrological model. The first step is identifying points of interest. The location of a stream flow gauge is a mandatory point of interest in the hydrological modeling WEAP. You can consider water intakes, discharge points, and any other point of interest. WEAP is a semi-distributed model. To explore the natural stream flow in a river ridge, it is necessary to include points of interest. Adding a river and not including any intermediate points of interest will only give you results at the end point of the river. The second one is defining the basins to each point of interest. The third one is defining if elevation bands will be included. Suppose that the basins delimited in the second step have a large extent and there is a significant spatial climate variability. In that case, it is worth defining elevation bands to capture the spatial variability of the climate. We will need a digital elevation model and analyze the spatial distribution of variables such as precipitation and temperature. The fourth step is intersecting the basins defined with the elevation bands. The intersection between elevation bands and basins, which are those portions of the area represented by polygons in a shapefile, are called catchments in WEAP. The steps from 1 to 4 define the extent and the limitation of the catchments. The steps from 5 to 7 are related to the data structure to be defined in WEAP. That structure must characterize the hydrological processes within the catchments. Depending on the method, WEAP can simulate processes such as evapotranspiration, accumulation, melting of snow and ice, runoff, irrigation, and agricultural and non-agricultural land yields. It is necessary to parameterize the model by assigning the hydrological parameters to the catchments. These processes may depend on the type of land cover, geology, and geomorphology, among other factors. You must define which disaggregation within the catchment will be used to represent these processes. For example, the catchments can be disaggregated by the land cover soil classes. The sixth step is estimating the areas according to the disaggregation defined. The seventh and final step is processing climate data. These variables are processed by catchment, not by the disaggregation defined. As an example of the disaggregation that can be defined, considering these maps and using a geographic information system, you could make the intersection between catchments, soil, and land cover. As a result, each catchment will have a subclassification of 108 classes corresponding to the combination of soil and land cover classes. If this were the study area, we could follow the steps we have seen previously to define the catchment and their structure. In this example, the points of interest correspond to the location of streamflow gauges. According to the streamflow gauge points, 3 points were defined at the mouth of this stream and upstream and downstream. Next, the basins were defined from the points of interest. Then, elevation bands every 100 meters were plotted. You must define the elevation bands. Because it was not a large area, elevation bands will not be used in this example. You must decide if it is worth defining elevation bands to capture the climate spatial variability. In this case, there will be 4 catchments. We can continue defining the catchment disaggregation and estimate the areas for each class within the catchment. In this example, the catchments were disaggregated by only land cover classes. It is important to define a disaggregation that helps you parameterize the hydrological model so that the water balance components can be represented properly. If a hydrological model in WEAP wants to be developed and the components of a water balance want to be explored, catchments must be defined following the recommended steps.